Good morning to everyone. In this presentation, I am going to discuss about all source shortest path. The mechanism is called as Floyds algorithm. The difference between Warshall's as well as Floyds algorithm is, in Warshall's algorithm we have used connected as well as unweighted graph for identifying the shortest route. In case of Floyd's algorithm, we will use connected weighted graph. That is the main difference between Warshall's as well as Floyd's algorithm. In Floyd's algorithm, we will choose all the vertex as the source. That's what it gets the name it as all source shortest path algorithm. Here I am going to take all the vertex in a given graph. All the vertex I will consider as a source at one time. Then from that vertex I will find out the shortest route between all other vertices. So now this is this Floyd's algorithm is an example for dynamic programming, and this algorithm is used for find out the shortest path in a weighted graph with positive as well as negative weights. In Warshall's algorithm we won't use any negative. In Dijkstra algorithm will not support for negative weights, but in Floyd's algorithm will support for negative, and there is no negative cycles. It finds the length of the shortest path between all pair of vertices. So consider this example A, B, C, D. There are four vertices are available. There is a path from A to C. How can I go here is, first I can move from A to B, then from B to D I can reach, or otherwise from A to B I will go, then B to C, then again C to A I can go. Otherwise I will go A to C, then C to D. Then I may have a path to A, B, C, D. So there are different routes are available. So when I find out the distance, ABD means from A to B weight is 2, B to D weight is 5. So totally 2 plus 5, 7. ACD means A to C, C to D is 7. Likewise ABCD means A to B 2, B to C 5, C to A to B is 2, B to C is 1, so 3, then C to D is 3, 6. So totally the cost of the path is 6. Next, it can be more than one route between two nodes. Yes, because in B, for a node B, B to C, either I can move from B to D then D to C, or I can move from B to A then A to C. From both of the thing I have to choose the minimum value. According to that the path must be exist. According to that we have to identify the shortest route, and there can be more than one path of the minimum length. Then next consider this one. For this we have to first of all we have to construct a adjacency matrix. From that adjacency matrix we have to compute about the intermediate node for all the nodes in the given graph. So here there are 4 nodes are available. So the number of node is 4. So there must be 3 iterations. Then the distance table will be D0, D1, D2, etc. Tn. Sequence table will be S0, S1, S2 up to Sn. Iteration will be K. Consider this example. Here in row wise I have written ABCD, column wise I have written ABCD. First, there is no self loop is exist, because this graph has connected weighted graph, but there is no self loop. So all the diagonal element will be 0. So A to B direct path is existing, so weight is 2. I have written 2. A to C direct path is existing, so the weight is 4. So I have written 4. But A to D there is no direct path, so it been represented as infinity. Likewise B to A path is existing, weight is 2. B to B there is no cycle, so it will be 0. All the diagonal element will be 0. B to C weight is 1. B to D direct path is exist, so 5. Likewise C to A weight is 4. C to B weight is 1. C to C no cycle exists, So 0, C to D 3. Likewise D to A no direct path. So infinity. D to B weight is 5, D to C weight is 3, D to D there is no self loop, so it will be infinity. So likewise we have to compute. When I am going to find out D1 matrix, for that I have to consider about D0 matrix. In D0 matrix I have to choose first row and first column, I must keep as it is, and also there is no self loop is existing, so all the diagonal element will be 0. So next, when I am going to find out B of B comma B is 0 because that no self loop. B comma C, how I am going to find out means, if I consider A as an intermediate node, then B comma C will be B comma A plus A comma C from this given graph. From this A0 matrix, B comma A plus B comma C is 2 plus 1 3. So that will be represented, and before that B comma A, B comma C is what? B comma C in the given graph is 1. So when I am going to find out the calculation, it must choose the minimum value. B comma C is 1, but when I am applying the transitive rule here, B comma A plus A comma C, B comma A is 2, A comma C is 4, 6. So 1 is less than 6, so I will choose 1 as a corresponding value. So this is the, likewise I have to find out the transitive rule for all other vertices in the given graph. So if Dij is greater than Dik plus Kij, then D1 of Ij will be calculated as Dik plus Dkj. Otherwise D1 of Ij will be D1 of Ij. So this is the method we are going to find out. When we are choosing another vertex, second vertex, in those case I have to choose second row and second column from the first matrix. Then I have to paste it in this given matrix. Then here also all the diagonal element will be considered as 0. A comma C will be computed as, now B is an intermediate, A comma C will be computed as A comma B plus B comma C. So from this matrix I have to compute A comma B plus B comma C. So if that value is less than that, then the minimum value will be written over here. So likewise next I have to choose C as an intermediate. When I have taken C as an intermediate, from the A2 matrix I have to copy C rows, the column as well as rows of C value, then I have to paste it. All the diagonal element will be 0. Then according to the transitive rule we have to find out the shortest route. Then at last we will compute for D matrix. In D matrix I have to choose 4th row 4th column of C matrix, I have to paste it over here. Then for computation of the shortest route I have to apply the transitive rule for find out the shortest distance. So when I am going to discuss, when we are think about time as well as space complexity, the time complexity will be order of n cube, space complexity will be order of n square. Then the applications of this Floyd's algorithm is, this algorithm is shortest path in directed graph and transitive closure of a directed graph. Then inversions of real matrices, it's an optimal routing, maximum bandwidth paths, it computing canonical form of difference bound matrices. This is all about Floyd's algorithm. Thank you.